Welcome to our lecture online, and here we're going to look at something very special when we deal with geometric series. We're going to deal with the finite geometric series. Here we have a series that actually declines in number, in size, as we go on, and starting with 1, then 1/2, 1/4. So again, we know it's a geometric series because we're going to find the common ratio. We're going to take any one number divided by the previous number. For example, we're going to take 1/16 and divide it by the previous number 1/8, which is equal to 1/16 times 8/1, because when you divide by fractions, the same as multiplying by its inverse, you can see that this is equal to 1/2. So that's a common ratio, it's 1/2. So each next number is half the size of the previous one. So if we want to find, let's say, the 7th number or the 8th number, let's see here, 1, 2, 3, 4, 5, 6. Yeah, let's say I want to find the 7th number in the series. How do we do that? Well, here we have, this is S sub 7 is equal to A sub 1, which is the first one, times the common ratio, which is 1/2, raised to the n power, where we're looking for the 7th one, minus the first one in the series, all divided by the common ratio minus 1, which is 1/2 minus 1. Excuse me. So let's work that out. So 1/2 to the 7th power is equal to 1/128. So that's 1/128 minus 1, all divided by 1/2 minus 1. That's minus 1/2. Okay, 1/128 minus 1, that would be minus 127/128. So minus 127/128 divided by a minus 1/2. So the minuses cancel out, and divided by a fraction, same as multiplying by its inverse. So this is equal to minus 127/128 times 2/1. Of course, that's minus 2/1. The minuses cancel out, so this is equal to 127/64. So that would be the sum of the first 7 terms. 1, 2, 3, 4, 5, 6, 7 would be 1/64, and that's what this is equal to. And of course, that is slightly less than 2, so that's almost equal to 2. All right. So that's how we find the sum, just like before, of the first so many terms. Now, what if we want to find the sum of all the terms out to infinity? What will that number be equal to? Now, that's kind of interesting because the numbers get smaller and smaller as we go out. So to find the sum of the entire series out to infinity, what do you think we're going to get? Well, let's find out. So we take the first one, which is 1, times the common ratio, which in this case is 1/2, raised to the infinity minus the first one, all divided by the ratio 1/2 minus 1. Now, what is 1/2 to the infinity? Well, 1 to the infinity is still 1, but 2 to infinity is an infinite number. So this becomes equal to 1/infinity minus 1/1/2 minus 1 would be minus 1/2. And so this number becomes 0, because anything divided by infinity is 0. So this now becomes minus 1 multiplied times the inverse of the denominator, which is a negative 2/1, which is equal to a positive 2. So you can see that if you just keep adding terms out to infinity to the infinite term, the total number of this particular geometric series will equal 2. So that means that the more terms I add, the closer and closer and closer I will get to 2. And eventually, if I add an infinite number of terms, I get 2. So in this case, this particular series converges when you add an infinite number of terms. That's not always the case, but in this case it is. And that's how you check that. So a very special case of a geometric series, and it's called the finite geometric series. Oh yes, there was one more thing I wanted to show you. Find the n, which number in the series is it if the a sub n is 1/128. So to do that, well, I'm going to need a little bit of room, so I'm going to erase some of the board here so I get a little bit more room. All right, take this example out and copy that down. So we have a sub n is equal to 1/128, and what is n equal to? Question mark. And of course, we know that the nth number of a geometric series is equal to the common ratio to the, well, let me see here. All right, yeah. So it's the first term times the common ratio times the n minus 1. There we go. I forgot the formula. All right, so if a sub n is 1 over 128, so we get 1 over 128 is equal to a sub 1, which is 1, times the common ratio, in this case is 1/2, raised to the n minus 1. So that would be n minus 1 like that. So how do we figure that out? Well, simplifying this just a little bit because we don't need the 1 there. So we can have 1 over 128 is equal to 1/2 raised to the n minus 1 power. So we can solve that by taking the natural log of both sides. So take the natural log of the left side, natural log of 1 over 128 is equal to the natural log of 1/2 raised to the n minus 1 power, like that. And of course, the rules of logarithm tells us that we have the log of something raised to a power that can go into the front. So now we have the natural log of 1 over 128 is equal to n minus 1 times the natural log of 1/2. And then we can divide both sides by the natural log of 1/2 to isolate n minus 1. So here we can write that the natural log of 1 over 128 divided by the natural log of 1/2 is equal to n minus 1. And now we're almost there, because if we now add 1 to both sides, we can now say that the natural log of 1 over 128 divided by the natural log of 1/2 plus 1, because I put the minus 1 to the other side, that equals n. And now all I need is a calculator to figure out what that is equal to. So 1 divided by 128, take the natural log of that. And then divide the natural log of 0.5 equals. And then we add 1 to that plus 1, and we get 8. So in this case, we can see that this is equal to 7 plus 1, which is 8. That's kind of a neat way to find the n. What term is it? What number are we dealing with if the nth number is 1 over 128 in this series? Okay, and that's how you do that.